hate this because I think that this is a point that's easier for industry to make than people who are, have been professors for longer, because what it needs is to buy in from the students. And the point is really that it's really hard to form up tasks and to do that aspect of deciding what to do without that intuition about language. And so we see all the time, basically people forming up tasks and expecting that stuff to be easy. And this is all things which, Ines was covering in a talk, but stuff like, people expect that, they can say, I want to see how similar to texts are. And they expect that they know what that means in a simple way. But, there's all sorts of semantic relationships that two pieces of text can have. And this sort of simple point that, people should understand this, and people, if they're going to be using a model that claims to do similarity, they should understand what that types of relations they're actually hoping that model will capture, and what types of relations they're hoping it won't capture.
Thank you, Matt and Ines. So we have, so Ted, do you want to go next? Do you want to ask your question?
Yes, thank you. I just, I've noticed that we have a significant portion of the Spacey team with us, and thought I would take advantage of that and just ask, in your views, for those of us teaching, let's say undergraduate NLP classes, or graduate for that matter, when and how is an appropriate way to introduce Spacey to our students? Like what's kind of your recommendation about the best way to do that?
Yeah, so I think, I briefly also in the talk mentioned the library APIs as like this kind of skill you acquire along the way. And I would say, I'm not necessarily sure that these the teaching approaches where, you really start with just teaching library APIs is a good way to go. So even though, we think Spacey is great, and we're very happy to see Spacey used among students because it's productive, I'm not sure I would recommend to just say, hey, let's start with Spacey and tell people that, oh, if you want to do NLP, here's how you should be doing it. Here's the API you should be learning. I do think it's more something that people, or we would hope people come to a bit more naturally, because if, you're solving certain problems, and I think the best way to discover tooling is by having a problem and then understanding how a tool solves it, rather than starting with a tool and then slowly figuring out what it's good for. But I do think that Spacey could definitely also be interesting when it comes to looking at the stuff that's a bit more around structuring projects, building pipelines, organizing code, ensuring reproducibility, because especially Spacey 3 has features for all that. You can, train transformer-based pipelines with whatever you need. You can have the config that represents every hyperparameter, and it's just a very structured way of working. So I think that's actually probably where it could fit in better than if you're teaching, I don't know, dependency parsing or something and want to look at some parse trees. I would say it's a bit less relevant for that. But yeah, for the more industry strength type of stuff and workflow stuff, I think it could be cool.
Thank you, Ines. David, do you want to ask your question?
Yeah. I mean, great talk. Huge fan of all the stuff you all do. My question is somewhat tangential to the talk. So I get students who take NLP courses and they fall in love with NLP and they're like, oh, I need to do more. And I'm thinking of how you've just created this super successful business. I mean, we all look to you to use it for industrial tools. And I'm wondering, aside from linguistics, what course should I take? What other things do you wish you knew going into this that is it business? Is it communications? Is it PR? I don't even know. Are there skills that you're oh yeah, I could have used that? Clearly you have it now. So.
Yeah, that's a good question. I mean, I think there's stuff around running a business where it makes sense to, I don't know, understand how to do these things. I do think more generally, programming is definitely something that, you kind of, pick that up along the way. I'm not sure it's necessarily something where I'm oh, I wish I'd done a course in that. But if people are interested in doing NLP, I think really getting really solid on software engineering and not just like using library APIs. That's definitely something that's very relevant, and you know, even going a bit further than maybe you might feel you need. Like, yeah, you can write code in like a Jupyter notebook, but then I think that there's this little bit of extra that I think can make a difference. Otherwise, Matt, do you have any ideas? I'm still thinking.
I mean, you know, again, it's we often are reluctant to say too much about these things because it's kind of overwhelming to people. You say, okay, you need this, and it's like the points in the skill tree that, you know, you're advocating for to start to grow and grow. And you know, I think when people are getting started, it's like more useful to be thinking about exactly what you're trying to do at a moment and be more purpose driven in that way. I would say that if we're looking at, you know, how people sort of develop as they're going through and just sort of, you know, doing this, like, you know, hill climbing or local maximization of their learning, I do think that people spend a little bit too long without going back and getting good at programming in memory managed languages, because you can waste an awful lot of time trying to make Python code like less horrible for performance, and you're writing code that's way less readable than decent code in a memory managed language, while also being, you know, harder to change, harder to understand, and also performing much worse. So there's sometimes where you know, should have that fluency to drop down and just like write code in a language where you can write a for loop. And I think that that can be very helpful.
Thanks so much.
Thank you. So now I'm going to read some questions in the Google Doc. So one question is, would you agree that linguistics is only necessary with word tokenized data?
No, I mean, it's still like, I mean, data, whatever, but if it's language, then yeah, of course. I mean, there's still going to be words, there's still going to be semantics, there's still going to be stuff that people are expressing in that text, whether you split it into, I don't know, white space, delimited chunks or word pieces or nothing, it sort of doesn't matter. You still need to have to apply the same reasoning about the language than you would otherwise.
Yeah, and look, I think a problem here is that auto linguistics is, you know, in the field is often done in the part where the data set is created or the tasks are defined. And so by the time you've got a data set with something to predict, all the work has gone into that to like actually make it so that the thing is reasonable to predict. And so people don't see that part. And so, you know, if you then have to come up with the task and come up with a way to solve a problem with NLP, people don't appreciate that, like, oh, actually, you know, it's not simple to think about whether this problem makes sense or whether you're all edge cases or whether you're actually coming up with some reasonable thing. So, you know, people expect that they can get a model that just does sentiment, as though that sentiment is, you know, something that is coded in the language directly rather than a task specific label. And so, or, you know, they expect that they can, you know, identify these spans that indicate something if that, you know, and when the thing that they're trying to identify would be a meaning that is encoded either across a whole predicate argument structure or perhaps even over the whole discourse. So, you know, having that understanding of like, you know, what will be reasonable or what's a reasonable guess to have a task at all is something that people really need. And, you know, that's all linguistics. It's not the case that people, you know, think of it as like, oh, I need to know, you know, certain details or something. It actually goes sort of much broader, and understanding things about semantic relations is definitely something that people are not doing well at the moment, and it's causing a lot of trouble for people.
Thank you. The next question is, currently NLP classes are mostly focused on, generally speaking, how does Spacey work, with hardly any how to use Spacey to do useful stuff. So what would a course of the second kind look like?
Oh, that's a good question. Hi, Yoav. No, I mean, I think I agree with that. And I do think it kind of ties in a bit into what I previously talked about, how, well, if you want to, you know, use Spacey to do useful stuff, you kind of need to start at the useful stuff. And then you can go back and find a way to do that useful stuff. Whereas if you start with the tools, and are looking for a problem, that's where it gets difficult. Or that is something we see a lot as well. We have, if people are not coming in via a different domain expertise that they have, where, I don't know, they're working on social sciences, they're working on legal or whatever, and upskill into NLP, they often bring the problem, and they're often quite successful, assuming they get good at NLP and good at programming. Where it is more problematic is if people are coming in from just NLP, and then they come in with a hammer and are looking for nails, and then they bang everything they can find, and it's not really working. So
so
I do think
my
that
question was more like, so as an instructor, you could select a nice set of nails with like various shapes and sizes to kind of just like show them like what things can be done, or like what are useful tools and problems, and then kind of how to kind of use them. And we don't have kind of good selection of these problems. And maybe you kind of are more familiar with, or others here with this kind of.
I think it's interesting, because I was kind of talking with Matt, while I was working on this talk about like, oh, what could be some ideas for this, and I think actually having people in industry bring their problems and kind of, for example, give you like a spec of like, here's the problem, here's what we tried, here's what ended up working, and then that's something you can work with, and maybe have students try to solve the same problems, try to analyze it and discuss it. Because again, I think where it can get problematic is if you have people who are teaching and who have no background in applied NLP necessarily, which is fine. Like it's, but then you can easily end up coming up with these fake problems that sort of, I don't know, everyone knows that from school, where like you do these maths problems that are supposed to be real, and everyone sitting there is like, it's not, like it's just this funny story around it. And I think there's a potential risk there. Also, things can be outdated. You can potentially, I don't know, cause more harm by teaching these useful approaches than good. But I think, that could actually be a useful industry academic partnership. If you have people in academia, just in an industry, just bring in some example problems and solutions.
Yeah, it could be especially cool if we can get the industry people to agree to mark the questions. So imagine there's like these discussion questions, right? And, they've come up with this question about like, a problem in their like situation, and they're like, oh, what should you do? Or what seems promising as, how could you use NLP to like, improve something here? And then rather than the teacher marking it and the students thinking like, oh God, the professor I just got to guess what they want to think. It's like, no, you've got to guess what your future boss might want you to think, and which, they can kind of get behind more. So, I think that could be valuable to people in industry, and they get to see some student responses and have an idea of who to look at as interns. And then also, they can mark the discussion questions, which I'm sure always has a nice benefit too.
Yeah, I really like that idea. Okay, so the next question is, in industry, how do you see the value of knowing how to use tools versus knowing how to implement algorithms from scratch?
I mean, I think I would say it's both important and relevant. I guess I don't know if I want to use this classic analogy of like, oh, you don't need to know how a car works in order to drive it. It's a bit like, meh, but there is you can just use a tool without necessarily knowing what's going on under the hood. But like, quite quickly it is always helpful to have the fundamentals. But again, I think this is easier if you also have something you're actually trying to solve and something you're trying to do, where you have a problem, you find a tool that does it, then maybe you want to do something slightly custom. Then you start thinking about, okay, how does this actually work? What does it do? And I do think in machine learning, understanding how a machine learning model works and what it does is incredibly useful and very relevant. And you cannot decouple that from just using a tool to get the job done. And if you do that, I think this is a great recipe to build actually harmful systems, because you'll be trying to do something that maybe can't work, or where the result you get out at the end doesn't actually mean what you think it does. And then when you put it in your application, it does something that you might have not intended or even thought of. So I think it's both it's both important, and I think you kind of need both. And at least I don't think you can really solve real world problems well if you only have one or the other.
Great, thank you. Any other questions, comments? Oh, Ted, go ahead.
Sorry, I'm probably talking too much, but I just wanted to say I really liked the restaurant cooking analogy a lot.
Oh, thanks.
And I've been thinking about it. I was a line cook in high school and college.
Oh.
And so the thing I thought about when you were making the analogy, especially about that little factory, there is so much parallelism and so much timing going on. Like things have to happen, you're putting together an order or whatever. Things have to happen in parallel so they all come together and everything is fresh and hot and served. And so there's like a whole thing you can work with there with that analogy. And I don't know, I just wanted to mention that I think it's a really good analogy. And I don't know if you have anything more you want to say about that, but I really liked it.
Yeah, thanks. Because actually, I did go through this a lot deeper than what I presented in talk. Because when you use an analogy, you kind of want to make sure that it holds up and that it's not like, oh, as soon as the first edge case comes in, you're like, nah, that's not kind of how it works. And there are a lot of things that really work. And it's the same with like pushing the boundaries. And how, just virtuoso skill or something doesn't necessarily scale and doesn't work. Like you can say, oh, I'm really pushing the boundaries here in my restaurant. I'm going to serve chicken sashimi and like, really go really up there. And that's fine. You can do it. You need to pull it off. But like you'll end up with this very, very narrow margin for error. And you really need to make, then you can't go to the supermarket and buy your chicken. You need to make sure your chicken's best quality. You need to make sure your people are top quality. You need to have processes in place, because one plate you send out there that's bad, that's like literally, critical, and that can like kill someone. So, and I think we even found like some, what's that, like Heston Blumenthal or someone's restaurant that I think Matt was telling me that story about, like how they actually did end up with salmonella because they were pushing the boundaries too hard, and then it all came crashing down. And I think it's the same thing. You can say, oh, I just have people who are really, really good at what they're doing. And it's like, yeah, that's fine, but you do need everything around that. Or you can say, oh, I'm really using this custom idea I thought of and this crazy model, and like I'm doing that, but it's like there's a risk you cannot, and it's interesting. It does hold up in these ways as well.
It's actually a great example of kind of potential harms. A restaurant isn't intending to or thinking about, killing people, but if they're careless, they surely can.
Yeah. Yeah, and it can be really just not being naive and not understanding some basics of food science, or like why you cannot do this, or why this is not the right dimension to push the boundaries on, and that can have very significant effects in ways you might not anticipate. Yeah.
David?
Yeah, so I love Spacey, but I'm also like a huge fan of the Prodigy annotation tool. Like it's such a great interface, and it does so much. And I feel like in NLP courses, we don't often talk about annotation and where our data comes from. It just like emerges. And I was curious, like what role you see that play in industry. I mean, you built this tool to solve a need, and like,
yes.
Well, yeah.
Yeah, I mean, it basically, really early on when we started out, it came, we initially, in the first few months of Explosion, we did a few consulting projects because we didn't want to raise investment money. We also wanted to see what are people building. And then that was a couple of years ago now. And the first thing immediately comes up all the time is people need data and they don't have it. So they throw it on Mechanical Turk. They get it back with like a prompt, like, I don't know, annotate whether these two texts are similar. That on that sort of level. And then it comes back and it's like, oh, the data is bad. And it's like, ooh, surprise, surprise. And so that was already something we saw immediately. And also we wanted an annotation tool. We always knew we wanted to create our own data assets. And of course, that's what we want to do. And so we built something that we wanted to use. And we also immediately saw that there's this huge need that's something people want. And again, I think that's where industry and academia are different. It's yes, creating data sets, of course, it's an interesting area. It's probably also unfortunately an area that doesn't get as much attention. If someone can decide what kind of paper they want to work on, what they want to do, you can create a data set, or you can grind on some baseline. There are some incentives that unfortunately kind of skew it against that. But even then, it's the idea of a data set. If you're solving a problem, is just different. You want to build something that really represents the utility that you're looking for. Whereas, if you're researching algorithms and models, you want something that you can compare and benchmark against. And there's just this very different role.
Sorry. Do you think there's something we should teach about creating data sets that like?
Yes, I think that's that's actually one of the big things that are definitely missing. And it really, it ties in about just the basic experience of being confronted with an annotation task and the data and having to do it. I think even that can be quite eye-opening. Even just simple prompt of like, we need to annotate all names or all, I don't know, person names already. After like 10 examples in, you already have like some interesting conflicts that you can discuss. Should we include doctor in the names? Is Snoop Dogg a person? Stuff like that. I think even just on that level, it can just be interesting to be confronted with that. But yes, in general, I think the data process is a huge part of building any system that you don't have if you start out with a data set that's pre-made for you by someone else.
So my advisor, James Kyron, had a component of an NLP course where he had the class annotate some data and also work on like defining the task. I think it was like classifying Wikipedia pages or something. And then I think it was nice because you can tell people that like the world doesn't divide neatly into an ontology, but in people's head they still expect it to divide neatly into an ontology, and they have to end up like in this moment where they find themselves arguing whether like your forehead is a part of your face or not, and two people have very ideas that this is completely obvious, and they're both very confident that the answer is like and the other person's like crazy, that you see like, okay, the world isn't like made of those categories. That's everything like is all edge cases in these things. And so I think you have to have that experience before you like really intuit that point. And so I think it's a good thing to have in a class, and people need contact with the data, that you can tell them this, but they won't really, and you can make them write it down on the exam, but they won't really act like it's true until they've actually encountered that problem.
Yeah, I think another relevant aspect is that the part of actually designing the label scheme. That's also something that I feel like I haven't seen a lot in courses in general, because it often starts at least at, hey, we're training a named entity recognizer, label the data for it. But usually all the work, or the most important work, starts a lot earlier, where you can decide how you want to create your label scheme and how easy you want to make your problem. And that is in a way something that is a bit unique to industry, because you start by, how easy can I make this problem for both the annotators and my machine learning model, and how can I set up my evaluation to be useful? And that's quite different from saying, okay, what data set can I find that has the hardest, trickiest problem, and how can I build a system that can solve that? And how can I use the same evaluation for everything so I can compare it? And how easy can I make something that's quite, I think we often see that's quite unintuitive to people. I sometimes feel like people almost feel like this is wrong, like harder is better. It's not sophisticated enough. If you are making it easier, you're cheating, it's not real enough, when it's actually it's the opposite. You should be trying to make it as easy as possible. That's good. And I think there could be something that can be taught around that could potentially be very interesting and relevant.
Yeah, so you're saying it as if it's kind of only an industry thing. The thing also in academia, you want to come up with a hard problem, but then the solution could be how to change it into an easy problem, right? So that's a kind of what like reductions are for. That's fine. Like that's what we do, I think. So like, yeah, you should do this kind of challenging semantic thing that kind of is really hard to model, but your solution should be simple.
Yeah.
It's a different type of hard and easy though. I mean,
Yeah.
you know, and a lot of NLP work is going into how can we frame like, you know, understanding tasks or something that actually scale up in complexity and difficulty while also being annotatable, so that, you know, we can prove that larger transformers are better. But, you know, I think
you
it's,
could argue
you know,
that
it's
this
just a
work
little
should
bit
not be
different.
done, but yeah.
Anyway.
Great, excellent points. So we have one last question, but I don't know. Do you have time for one question or?
Oh, sure.
Yeah, just yeah.
Yeah.
Okay. So there is
it's like 9 a.m. for me. I have
oh,
all day.
okay. Okay. So the question is, what if you want to teach low resource languages like the indigenous languages of Peru or Mexico? So many of the industry tools only work for languages with a lot of data. And so should we focus on making the classes with algorithms from scratch and highlighting the linguistic aspects of each language? I mean, I guess maybe for you, the question is probably, do you just work for languages with a lot of data, or do you also work with low resource languages?
I mean, we want to provide a toolkit that lets people implement systems in whatever language they're working with. I think that's important. And yeah, it's still true that you do need a certain amount of data to train a system. I do think it's becoming a bit easier. Also, what's becoming a lot easier is if you actually, it depends on what you want to do with that system you train on the low resource languages. But if there is something you want to analyze, if there's something very specific you want to do, there's also an opportunity there to, create your own data sets that are a bit more specific to what you're solving. And, you don't have to, if your goal is not to build one language model to rule them all and to do everything that you can for a given language, then that also opens up a lot of possibilities. But it's obviously true, like we all know that, like, well, NLP works best for languages the closer they are to English. That's kind of, that's the ranking. If your language is English, then yeah, it's going to be easier. And that is not, that's not something that's inherent in the language. That's more inherent in, the technology that we're building. But
I would also say that, for many of the sort of practical applications, practical use cases that we imagine Spacey for sort of stop making so much sense if you think about a low resource language. So it tends to be something where either people are transacting in the language, like, on the internet, maybe there's like a marketplace or like something like that, or somebody's publishing bulk information, or they have like a bulk data store of documents that like a company has had in the past. All of these things don't really like match up very well for low resource languages. And so then we've had people discuss like, making like, Spacey pipelines in low resource languages. And like, we're happy to support this, but a part of me, I always wonder, like, is this effort that should be put more towards like more organized language preservation things? Because, the work that you do into making a Spacey model to do something isn't necessarily going to be optimal. And there's, just seems like such a shortage of effort to go around on low resource languages collectively, that I would get nervous about advocating for, Spacey pipelines for low resource languages. It's like, they don't seem to have, such a practical use case. And I really struggle to believe that that's the best thing that we should be doing for low resource languages.
Okay, thanks for sharing that. Any last minute comments? If not, let's clap again. Yeah, thank you very much.
Thank you.
Yeah,
thanks. This was a great discussion. I had a lot of fun. I got up really early for this, and it was great, and it was worth it. So
yeah, and your pre-recorded talk is on YouTube, so that's great. And the recording will be made available. The Q&A recording will be available sometime whenever we get it from Underline. I interrupted someone. I think someone was talking. No? Okay. Okay, so thank you everyone, and we will see you tomorrow. Bye.
Thanks, everybody. Bye-bye.
Hi, Rada.
Hello.
So
I would
yeah, we
to see if there is anything important in the chat. Maybe we should save it.
I mean, there were a
couple of
few
links
comments.
might be interesting, and maybe stop the recording.
Yeah.
Oh, right.
Yeah, I mean, I forgot to start the recording.